Welcome to episode 2 of our comprehensive AI series. In this episode, we delve into the fundamentals of machine learning, exploring its core concepts and applications. Stay tuned as we unravel the intricacies of this transformative technology. Machine learning is a subset of AI that enables computers to learn from data and improve their performance over time without being explicitly programmed. It's the science of getting computers to act without being directly programmed. Unlike traditional programming, where a programmer writes explicit instructions, machine learning involves training an algorithm to find patterns and make decisions based on data. There are 3 main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained on labeled data, where the desired output is known. In unsupervised learning, the model identifies patterns in unlabeled data, where the output is unknown. Reinforcement learning involves training models to make sequences of decisions by rewarding them for good decisions and penalizing them for bad ones. In supervised learning, we provide the machine with a dataset that includes input-output pairs. The goal is to learn a mapping from inputs to outputs. For example, in image recognition, the model is trained with images labeled with the objects they contain. Over time, the model learns to recognize patterns and can identify objects in new images. Applications include spam detection, where emails are classified as spam or not, and predictive analytics, where future trends are predicted based on historical data. Unsupervised learning deals with data that has no labels. The model tries to find hidden patterns or intrinsic structures in the input data. Common techniques include clustering, where data points are grouped based on similarity, and association, where relationships between variables are discovered. Applications include customer segmentation, where customers are grouped based on purchasing behavior, and anomaly detection, where unusual data points are identified. Reinforcement. Learning involves an agent that learns to make decisions by performing certain actions and receiving rewards or penalties. The agent aims to maximize cumulative rewards over time. This type of learning is inspired by behavioral psychology and is widely used in robotics, where robots learn to navigate environments, game playing where algorithms like AlphaGo have beaten human champions, and autonomous vehicles where cars learn to drive safely. Machine learning is revolutionizing industries. In healthcare, it helps in disease diagnosis by analyzing medical images and predicting patient outcomes based on historical data. Personalized treatment plans are created by analyzing patient data. In finance, machine learning detects fraud by recognizing unusual transaction patterns and optimizes trading strategies by analyzing market trends. Technology giants use machine learning for search engines, improving the relevance of search results, recommendation systems, suggesting products or content based on user behavior, and voice recognition, enabling natural language understanding in devices like smartphones and smart speakers. While machine learning has many advantages, it also presents challenges. Data privacy is a major concern, as models require vast amounts of data to learn effectively. Ensuring that sensitive information is protected is crucial. Model interpretability is another challenge, as complex models like deep neural networks are often seen as black boxes that are difficult to understand. Researchers are working on techniques to make these models more transparent. The need for large datasets is also significant, as high-quality, labeled data is essential for training effective models. The future of machine learning holds immense potential, with ongoing research focused on making models more efficient, ethical, and capable of learning from smaller datasets. Let's take a closer look at machine learning in healthcare. Machine learning algorithms are used to analyze medical images, detect anomalies, and assist in early diagnosis of diseases like cancer. For example, by analyzing thousands of mammograms, a machine learning model can learn to identify early signs of breast cancer with high accuracy, potentially saving lives through early intervention. Predictive models can also analyze patient data to forecast disease progression and recommend personalized treatment plans, improving patient outcomes and optimizing healthcare resources. In the financial sector, machine learning helps in risk management, fraud detection, and investment strategies. Algorithms analyze market trends, historical data, and economic indicators to predict stock prices and make informed trading decisions. For instance, a hedge fund might use machine learning to analyze vast amounts of financial data and identify profitable trading opportunities. Additionally, machine learning models can detect unusual transaction patterns that may indicate fraudulent activity, protecting both financial institutions and their customers from potential losses. In technology, machine learning enhances user experiences through personalized recommendations and voice recognition systems. Companies like Netflix and Amazon use machine learning to analyze user behavior and preferences, providing personalized content recommendations that keep users engaged. Voice assistants like Siri and Alexa rely on machine learning to understand and respond to user queries, improving their ability to recognize accents, languages, and even the context of requests. These advancements make technology more intuitive and user-friendly, transforming the way we interact with digital devices. In our next episode, we'll dive deeper into deep learning and neural networks, the driving forces behind many AI advancements. Stay tuned to our comprehensive AI series for more insights.